Hello everyone, my name is Mr. Asnagailu from Ethiopia and I'm a physics lecturer at Awasa University. Today we will discuss in detail about projectile motion. እኔ መምህር አስናቀ ኃይሉ እባላለሁ። በአዋሳ ዩኒቨርሲቲ በፊዚክስ የትምህርት ክፍል መምህር ነኝ። ዛሬ ጠቅለል ባለ መልኩ የተወረወረ ነገር እንቅስቃሴ ምን ይመስላል የሚለውን ነገር እናያለን። So before illustrating about the motion of a projectile, we have to know first the meaning of projectile. What is projectile itself? Projectile is an object that is run or launched with an initial velocity and then moves freely under the influence of gravity and then air resistance. But in most basic calculations, air resistance is ignored. Great. If so, what is projectile motion? Now, projectile motion is the motion of an object thrown or projected into the air subjected to only the acceleration of gravity. This type of motion is a combination of horizontal motion and then vertical motion. Look, my dears, projectile motion is two-dimensional motion in which the velocity of a moving object has x as well y component is. If an object is thrown with the initial velocity vi, that makes an angle theta I with the horizontal, its path or trajectory it will be concave down parabola. Such motion is known as projectile motion. So the angle of theta I is called angle of departure. Correct. Look this figure. This stands for or tells to us this is the velocity vector, the main velocity vector. So to narrate in depth about the motion of projectile, we have to decompose this main velocity vector into its component. And as this is its x component, and then it is equivalent with vi cosine of theta. This is its y component, and then it is equivalent with vi sine theta. Great. And then look, this is the maximum point from the thrower hand to the maximum point is known as maximum height. Another very important thing is key points about projectile motion. What are key points? ቁልፍ ነጥቦች ስለተወረወረ ነገር እንቅስቃሴ ቁልፍ ነገሮች። አንደኛ two-dimensional motion. It occurs in two dimensions, basically horizontal and then vertical. Another one is the horizontal component of the velocity remains constant because air resistance is negligible and then ignored, and hence the velocity along x-axis never be affected. Another one is the vertical component of the motion is influenced by gravity, resulting in constant downward acceleration. Another very important key point is about the path or parabolic trajectory. This is the path of the projectile is typically a parabola, even though or despite the fact that factors like air resistance can slightly change its shape. And as the path of a projectile seems to be parabolic trajectory or simply concave down parabola. Another very important point, or this is the key one, is the horizontal and the vertical component of the motion are independent of each other. Air resistance can affect the trajectory, but it is often neglected in basic calculations. So the maximum height and the range of a projectile depends on the initial velocity and angle of projection. If so, we can calculate the maximum height, the range, and then the total time of a projectile. The maximum height reached by a projectile depends on its initial velocity as well as angle of projection. Great. The formula for maximum height is h maximum is equivalent with square of v naught, square of sine theta over 2g. But we can find for the case of a vertical motion, we have to refer the equation of kinematics. And then we know that one of the equation of kinematics, square of v final is equal to square of v initial plus or minus 2gh. Hence, we may say square of v final of y is equal to square of v initial of y plus or minus 2gh. But in our previous slide, we tried to analyze something that we decomposed the main vector vi, or simply v, into its component. At that moment, we say that the y component is simply v initial of y is equivalent with vi sine theta, and then the initial component of s, the velocity along x-axis, is equivalent with v I cosine of theta. Correct. Now just substitute and then bear in mind the y component of final velocity becomes 0 at h maximum. So at h maximum, the square of v final of y component is equal to square of v initial of y component minus 2gh max. But v final, the value of v final of y is 0. And then we have to take the initial value of the velocity component to the left side, and then it becomes negative square of v naught of y is equal to negative 2gh maximum. Just eliminate both sides by negative 2g, and then h maximum becomes v naught of square of v naught of y over 2g. But square of v naught of y is equivalent with v naught times sine of theta. So substitute and then square it, and then it becomes the square of v naught times square of sine theta over 2g. In such a way, we can find the value of h maximum, where v naught stands for initial velocity and then theta is the angle of projection. So g stands for acceleration due to gravity, approximately now equivalent with 9.81 meter per square second. Great. Now our second attempt is range. But to calculate the range, we have to know something. First, we have to calculate what we call it the total flight of time, because it is very important to calculate the value of range. As you know, the range is the horizontal displacement of the projectile, and then it should be calculated like the product of average velocity along the x-axis and then the total time of flight. Great. But to do so, first we have to calculate the total time of flight. The time of flight is the total time in which the projectile stays in air. That means the total time is equivalent with the sum total of time of ascent and then time of descent. In absence of air resistance, time of ascent is equal to the time of descent. In such a case, what we have to do, if we find what we call it the time of ascent, we have to multiply by 2 simply. Therefore, the time of flight is equal to twice the time of ascent, the horizontal range of the projectile. Now, if so, we can calculate this time of ascent. Great. As usual, from the kinematic equation, we know that v final is equal to v initial plus at. Now substitute in terms of a vertical motion. We may say v final of y is equal to v initial of y minus g t of ascent. But at the maximum point, as we know, the final value of velocity is 0. And then take the v naught of y component to the left side, and then it becomes negative v naught of y is equal to negative 2g t of ascent. Just eliminate both sides by neg of g, and then t of ascent becomes b naught of y over g. Correct. But b naught of y means, as what we discussed, it is equivalent with b naught sine theta. So substitute it, and then it becomes t of ascent is equal to v naught sine theta over g. So from this time taken is equivalent with simply twice of t of ascent, that is twice of v naught sine theta over g. Correct. If so, now we are on the right moment to calculate the exact value of range. Correct. The range, as I said, the horizontal distance traveled by the projectile. Correct. It's calculated using the formula, and then we will find this value. But bear in mind, already we found the total to arrive to this point. We found the total time, that is twice v naught sine theta over g, one thing. So range is simply an average velocity times total time. Our average velocity in this case, because we ignore the resistance, so an average velocity is equivalent with the initial value of x component, that is v naught cosine of theta. Knowledge, twice of sine theta cosine of theta is equivalent with 2 sine theta. Correct. If so, range becomes square root of v naught sine 2 theta over g. In such a way, we can calculate the range. Already we discussed about the total time of flight. So the total time of flight is the time taken for a projectile to reach its maximum height and then return to the ground. Now the formula becomes as what we did, twice of v naught sine theta over g. Correct. How to calculate? Okay, how to calculate? To calculate the range, the maximum height, the total time, we have basic quantities. We have the initial quantities. The first important thing, we have to split, we have to break down, we have to decompose the initial velocity into its component, to its x as well as to its y component. This is very important to us. And then another very important thing is we have to use the kinematic equations for vertical motion to find the h maximum, to find the total time. We have to use kinematic equations, or we have to refer kinematic equations. Correct. And then another very important thing is for horizontal motion, okay, use the equation s is equal to ut, where s stands, or s is the range, and then u is the horizontal component of the main velocity. This is equivalent with v cosine of v naught of v cosine of theta, and then this is the total time of flight, and then the product of them gives the value of the range. So this is all about our discussion upon the projectile motion, my dears. If you have any doubt, you are welcome. Just inbox to me. Please like, subscribe, share my channel for your friends. Till the next session or discussion, I'm interested to say goodbye. Thanks a lot. Bye bye.